All right, welcome everybody. Thank you so much for joining today for Ultra High Performance Concrete Facades 101. This is presented by Tactile. We have Kevin Gannon on today. He's going to be presenting the course. And we also have Catherine Lynn with Tactile today. She'll be on board to answer any questions. So please feel free to submit questions to the Q&A box throughout today's webinar. We'll get to those, as they come in. We might have some time to chat through some of them towards the end. And if for any reason your question goes unanswered, we will have a record of it so that we can follow up after the event, get you the answers that you're looking for. My name is Bo. I'm with Acelab. We're helping out presenting today's event. My colleague Helen is here as well. She's our director of architectural experience. So I'm going to let Helen give a quick little intro about Acelab, show you how to get in touch with Tactile on Acelab, as well as how to use it for your product research. We're just going to do that for a few minutes while folks are joining, and then we'll go ahead and get started with today's course. All right, Helen, feel free to take it away.
Thanks, Bo. Appreciate the intro. Hi, everyone. So I'm going to pull up my screen really quickly here, and we're going to show you how to get in touch with Tactile after this for any questions you might have. And then I'll also give a quick little high-level overview of the ins and outs of Acelab here. So jumping into share my screen. And the first place that y'all are going to go is if you want to get in touch with these folks after the webinar, you can come into the main search home screen, come down here, make search.
We're still seeing Kevin's screen. Kevin, would you mind stopping the screen share?
Yeah, let's try that again. It said it was loading. Is that coming through now? No.
So Kevin, at the very bottom where it says share screen, the green button, if you just stop sharing there.
I'm not getting any buttons on the bottom. I apologize, but up at the top.
Do you see the little screen share button? It should be green with an arrow.
Yeah.
Right, 1 second. Let me, here we go. All right, I switched it.
There it is.
There we
okay,
go.
Thank you. Sorry, everyone. All right, so here in our main search bar, you're going to see brands, products, and resources. So we'll go ahead and type in the first little letters there for Tactile. Click on this, and then this will take you to Tactile's homepage where you can see all of their great products. And y'all can also directly contact Catherine here for anything that you might need, pricing information, lead times, things of that nature. So this is the home base for Tactile. And now I'll quickly cover home base for y'all. So if you come up here into workspace, just want to show you a couple of fun functions. One of them being the ability that y'all have to create a firm library. So you can save all of the products that y'all use a lot, including things like Tactile, into one spot. This is really a great tip to save time for new employees that you might be onboarding, as well as just keeping yourselves organized and starting up on new projects quicker. I'll show you one other little fun fact today, and then I will pass it back over to Bo so you can see we have all these different products. You can compare these as well. You'll get all this great performance data, but one other thing I really like to highlight is the ability for y'all to share this with your clients, your consultants, your contractors. And one other thing too is you can leave comments here, and that's really great to have a conversation with Kevin and Catherine, say on their Tactile products, or sorry, yes, on their products. And then you'll get a nice record of those conversations within Acelab. So that's kind of our overview for today. Acelab is free for architects to use. So if y'all want to set up a free training with me, 15 minutes, we can come talk about your firm's needs, and take it from there. So we'd love to connect with y'all, and I will pass it back over to these other folks. Thank you.
All right. Thanks so much, Helen, for that overview. Just launched a quick poll, so if you're interested in learning some more, feel free to fill that out, and Helen will reach out to you to schedule a time. All right. So now, without further ado, love to pass it over to Kevin to get started with today's course on ultra high performance concrete facades. Kevin, thank you so much for joining today, and feel free to get started whenever you're ready.
Thanks, Bo. Thanks, Helen. Now I'm trying to figure out how to get back to where I was. I've got something else on my screen that's keeping me from, I can't close this thing. There we go. And somehow we got in a different place with slides. Okay. Hello, everyone. So just a little bit about Tactile. We're a company located in Pittsburgh, Pennsylvania. We make facade panels out of ultra-high performance concrete. And today we're going to sort of go through some general information. Why can't I advance the slides? About, using the material, some of the basics. And so starting out, we've got some examples of projects recently completed. They're utilizing a number of different surface treatments, colors, and textures. These kind of projects range from, for example, on the screen, multifamily housing in New York City, to university buildings, hospitals, government buildings, labs, etc. So there's a full range of buildings of which our products are used. Some really kind of preliminary basics relative to the building code. So in the International Building Code, the reference standard for our material is cited as ASTM C1186. That's the specification. Inside of that is a whole range of tests that are within the C1185 battery. And then with the International Code Council, there are acceptance criteria. One is for AC90, which is for physical characteristics, and includes wind load testing, fire resistance, durability tests. Under durability includes warm and cold water testing, freeze thaw, salt spray, rain, etc. And then also within the ICC, there is AC10, which is the quality management oversight. And that's third-party audited, which means people show up unannounced. They go through all of our QC logs because we record all the internal QC checks. And then occasionally they take material right off the shop floor and do their own testing. Tactile is approved by the ICC for all construction types, as well as interior Class A. And then in addition to that, we have some regional things that we've gotten approval in Florida, Miami-Dade for hurricane, and as well as for Texas for high wind zone and hurricane. There's a few others, but I'll leave it at that. Generally, we're specified under Division 7, and that's for field set and some prefabricated wall systems in a kind of a rainscreen or ventilated cavity wall construction. We also find ourselves at times being specified in Division 8, and that's usually when we are integrated skinning curtain walls. Not applicable for us, and you could hear the tone of my voice. We very often see our material specified in Division 3, and it comes with a lot of precast concrete reference standards that do not apply to the material, and it's usually it's a big, for all intents and purposes, it's a big waste of time to then get it all sorted out, because you've got project engineers that then say, well, where's this test and where's that test? And it's a different set. And just to be clear, the Precast Concrete Institute and the National Precast Association do not have reference standards for thin textile reinforced UHPC. They are working on it. They've been working on it, but as of now, they do not have that. So what do we make? Well, we make panels, and those panels typically, we use the word standard. I'll clarify what that means in a second, but typically are 4x10, 4x12, 5x10, 5x12. All of those sizes can be made at 5/8 of an inch thick. We can make longer panels, but we cannot make wider than 5 foot, and 5 foot is a nominal dimension, which means net panel is 59.5 inches. Standard for us, all that means is that we have an inventory of a mold pattern, and we have 9 standard surface textures where we maintain an inventory of a large number of molds. After that, everything else about a project is pretty much customized. Everything is made to order. One of the important, probably not the highest, but the most typical cost factor to address is panel optimization from those standard blank sizes. And it's basically just about not wasting the material. So here's just some examples of how the sheet utilization goes down depending on the shapes or the sizes that you use. The two on the left, it's an interesting story. It was a great project for us for a lab building, and I kept calling the contractor saying, when are we going to get the drawings? And he goes, you don't need drawings. And I said, what do you mean? We put the sizes in the PO. And I was like, well, that's not how we do this. And he said, well, I don't know why you need anything else. There's only 2 different panels, an A that is a full sheet and a B that is a full sheet cut in half. And 40,000 square feet on a lab building was done with those 2 panel types. Very efficient use of the material, no waste, and no waste cost. And so there's 2 things: being efficient with the resources and being mindful of the cost. The more cutting, the more waste, the more unique parts, it usually has a cost impact. Not only for our material, but also for the hardware to hang in. We can do just about any color to a limit of 6% pigment load. So deep saturated colors are hard to get to. The panel example on the right for a project up in Wisconsin, there was a blue the architects wanted that we couldn't get to. But there's blues, reds, yellows, highly saturated, very expensive. The most saturated blue panel on this building in Wisconsin, the pigment costs more than all the other raw ingredients combined. So we are concrete material. It's mineral based. There's a whole range of raw materials that are all mixed together. And not only is the strength and mechanical properties of the material dependent on a curing process, the color is as well. So there will be color variation, just as there can be minor variations in every single ingredient that we're mixing. We do, I believe, a really great job of QC monitoring of everything, but variation should be expected. Now, some examples of a coarser product, which has an aggregate broadcast into the surface. This is, I would say, typical variation to be expected. When we do these types of projects where we have aggregate on the surface, there's always a question of, is it going to be randomized? How are you going to randomize it? How are you going to manage that? And another couple of projects that are both Corsa with surface aggregate included, we did nothing for either one of these to make sure it was randomized. It's one of the things that's great about specifying a Corsa finish is that you will naturally get variation and you will get it randomly. One of the other ways that intentional variation on a facade is done is by using different textures. So, and the interesting thing is the effect of those. So, on the left, you're looking at an overcast day, straight-on photograph of exactly the same thing that you're seeing on the right, probably early in the morning on a sunny day, there can be dramatic differences with very subtle texture. And speaking of texture, so as I mentioned, the panel's base thickness is 5/8 of an inch. So any texture, and the image you're looking at in this cross section is our Arbos, which is a standard texture. And you'll see that that texture is probably in the range of 1/8 of an inch, where it tops out in the peaks of that wave pattern. So any of the textures, most of the standard ones are within 1/8 of an inch in depth. They have a base thickness of 5/8. When we do custom work, we can go to a maximum overall of 1.5 inches, meaning you have to hold a base thickness of 5/8, and then whatever the relief or rib or whatever it might be is then added to that. And that's so that we are maintaining a base performance and a depth for our anchors if we're putting in concealed anchors to attach these panels. And I will say that the other factor on the limits is overall weight of the panel. So depending on the typical size panel for the project and then the overall thickness of it, there may be a place where they would bump up against each other. In other words, we wouldn't make a panel that is a solid 1.5 inches thick, that is 4 foot by 10, because that would exceed the weight that we can handle through our processes. So we talked about Corsa. These are some examples of that included in some custom surfaces and custom colors. Some other examples of patterns that we can develop and work with, everything from a fluted panel that fades to flat from one end to the other, to milled patterns to create a kind of meta pattern or large graphics across a facade, to sort of chunky in and out. By the way, that's Braille for giants on a building at UC Davis. We didn't know that until we told them they could just cut a panel. And they said, well, if we cut it, it won't say what it's supposed to say. And then we all try to figure out how anybody would actually read it. Some more examples. So when we do these patterns, sometimes we are given models and files from the architects. Sometimes we are given images, and then our team in the mold shop works with a variety of materials to create models and molds from the desired pattern. So some of these are milled on a CNC machine in our shop. That would be the one on the far left for sure. The gray small corrugation third from the left is actually molds pulled off of corrugated cardboard. So there's a whole range of materials we're happy to work with to get the end result. Crinkled paper and sand, chipping away at our own castings of ribs to make some organic and random patterns, wood, and so forth. We do at times make custom cast forms. So the image on the left is ribs and a cast corner. We made 1,200 of these that went into a curtain wall project. And our choice for doing cast forms is a factor of what's the repeatability of that, how large is the project timeline, and how that may or may not overlap with other commitments we've got. So it's not an everyday thing for us, but we can and will do it for special projects. So installation of our facade material. So this is the most typical, we've done more than 400 facades in the last 10 years. And a good 85% of them are installed this way, which what I'm referring to is a back ventilated and drained cavity wall or rainscreen, if you will. So a layering over top of substrate. That substrate could be concrete block, stud wall. More often than not, it's a stud wall. And you have a subframe with a continuous air and water barrier, continuous insulation, and then a panel rail system that can be either a C rail and clip, or it could be a hat or Z with a visible fastener for the panel. And then these days for us, about 50% of projects of scale are coming to us as prefabricated or curtain wall assemblies. So, and there's been acceleration of that in just the last 3 or 4 years. But this is an example for University Building in Cincinnati. We have done curtain wall projects where it is just like a ventilated cavity wall, where there is no seal of the joints. We've done some where they are dry sealed. We have done some where the joints have been fully sealed up. So there's a whole range of ways that is done. And there are no, I wish I could give you standard details, but every curtain wall fabricator has their own preferences on how to go about that. So we end up working with them very closely through the design assist phase to do those projects. And then we've also done a good number of, some call it mega panel, some call it large format prefabricated, but this is essentially a stud wall, just like the section I showed you earlier, but it's large wall sections that are built flat in a factory and then shipped to the site and swung into place. This example is the largest panels that we have had our material applied to. These are 12-foot wide and 40-foot tall. There were circumstances with the site that I won't get into that drove a prefabrication and a prefabrication with units of this size. But on the left, you can see the water barrier with girt brackets installed. And then as you go back into the perspective of that image, you'll see insulation on that, and then rails, and then panels. And so it's done just the way it would be on site, just laying flat under roof. And then it's a testament to some of our material properties that we'll get into, but we have been installed as the air and water barrier of the building. So this project is in San Francisco. It was a marriage of ourselves and a spray-in GFRC outfit in the Bay Area. So this is welded tube steel frames that if it was spray-in GFRC, those frames would be lowered and registered to a mold, and then they would have little steel hooks welded off of those steel tubes, and then they would just spray in, and the sprayed GFRC would be then basically bonded to its frame. The architects and the facade consultants involved in the project insisted that they stick with Tactile, so spray and GFRC wasn't going to go, but it needed to be prefabricated. So we had this marriage of us and a prefabricator that typically did GFRC for this project. So working with our material and corners, there's a number of different ways to do it. So there's a square butt corner where you simply have the cut edge, a joint meeting at a right angle with another panel. This works very easily. One thing to note is that a blasted surface of a panel versus a cast surface of a panel, there'll be more of contrast between the edge and the face. But when you have a blasted panel, the edge and the face are pretty much the same in terms of color and saturation, hue, etc. We can also place a miter on the edge of the panel. All of our miters will have a cork. We will never cut a panel to a knife edge because it's too vulnerable. And then we also bond corners. We actually do this quite a bit. And that's basically in the factory, we will epoxy them together. So I refer to this as casework with concrete, but we can make fairly large elements. There are limitations that we would address case by case, but you can see some of the variety of things. One of the nice things about bonding is you can switch colors or surface finishes within a bonded part, which you wouldn't be able to do in a cast part. So a little bit about us. We are located in Pittsburgh, as I said, in an old Westinghouse factory. We say historic because Tesla had a lab right in this building here. And at one point in time, this facility made everything from turbines for the Hoover Dam to toasters and everything in between. No poll question. Okay. So we're vertically integrated, and to tell you what that means, it means that everything from the design of the chemistry of what we're making through to the delivery of final panels all happens on our campus. And we have our material science has been evolved with our manufacturing so that it's very closely integrated. But we make all of our own molds, we do shop drawings, we do design work, everything from the same place. Our raw materials are sourced within 500 miles, at least 91% of them. And I would say that 75% are probably within 250 miles. You're seeing images of some mold making. So we use CNC equipment to make mold patterns. Sometimes we've been given a flash drive with a algorithm that tells the CNC machine how to carve a surface, and that's how we develop the molds. So we have a lot of capabilities in metalwork, woodwork, you name it, in-house here for mold development. Our panels are cut with CNC equipment as well. And they're drilled right basically in a continuous process. After it's cut, it's passed along the line for drilling. Then it goes to cleaning and whatever other special finishing needs to happen with the panels. We usually crate and ship our panels if it's a concealed attachment project. We're shipping them with the clips on them. And then we also at times prefabricate panels into larger sections. This is sort of a hybrid, not a full prefabricated wall, but prefabrication of the cladding to simplify connections and or achieve some special panel relationships for projects. Just a little bit about scheduling. We're usually involved in projects very early in the process with architects. And because delegated design, then there is a process with the installing contractors and the general contractors. This particular schedule example is for a design assist, and it's collapsed. So there's a lot of things that don't show up here, like the early design and detailing work, the mold development and design work, et cetera, engineering and so forth. But you get a sense that we build these schedules, but usually we're starting from the delivery date and working backwards. On our team in-house, we have architects, engineers, industrial designers, and so forth, which we believe makes us good collaborators with architects and facade consultants and contractors. The images you're seeing now are the first curtain wall project we did, which was back in 2014. As I said, we've done a lot more of them since. This particular set of images is for a building in Fairbanks, Alaska, where the main reason they chose to go with our material was because of its thermal stability and its freeze-thaw performance. In-house, we have mirrored a lot of the equipment that's used by third-party testing agencies, including weathering chambers, accelerated cure chambers. I don't have pictures of all of our strength testing equipment, but we have the ability to do a lot of the things that we ultimately get certified by a third party in-house. And some of the things that our research people are also involved in is the QC and process improvement. So there's this constant feedback loop from the factory floor to the lab and back. And our research and development team is also involved in project-specific solutions. So there may be, for example, a special aggregate that somebody wants to use. We need to test that and make sure it's going to all work. Some of the current things and recent things include SOLA, which is a photocatalytic UHPC panel. Corsa, as we've mentioned, and I've seen some examples of. And we are constantly looking for substitutions for pozzolanic materials to replace cement with recycled content materials. And we built our own impact testing equipment so that we can look at higher impact resistance, but not add thickness to the panels, which we think we're the thinnest and strongest out there. So that's sort of about what we make and who we are. I'm going to talk a little bit about the material science and the history of UHPC. So for those that may not be familiar with UHPC, it stands for ultra high performance concrete. Back in the day, in the early 80s, it was called reactive powder, and you'll see an image that'll tell you why. But it is a category of concrete that's recognized across civil engineering and a lot of other institutions. It's not a brand, it's a category, just to be clear about that. But it has not come into application to a wide extent until fairly recently. So it's been around for 40 plus years as a thing. But just to give you a sense of how recent its use has come about, the cross-section you're seeing of girders and a bridge deck is for Cedar Creek in Iowa, which was built in 2006. So, more than 30 years after this material was recognized and given a name and a category, it's not that widely used. But it's always used for its strength and severe climate or severe environments. So you see some precast beams, in this case being tested. You see even more recently some more complex bridge cross sections being precast and set into place, topping an existing viaduct in Switzerland. So this particular viaduct is like 2 kilometers long, up to 6 lanes, and they're topping the entire thing with about 1.5 inches of UHPC to add strength, wear surface, and waterproofing. And then this one, it's kind of sad to say, is what about 97% by volume of UHPC is used for in North America, is to fill bridge deck joints, which is just to say that it's selected from critical elements where weathering and salt and water, etc., it needs to have that kind of durability along with its strength. So when we talk about reactive powder, so this is a graphic example of the difference between a conventional concrete and UHPC. Much finer packed, much smaller stuff. So the largest grain of sand in UHPC is way smaller than the smallest grain of sand in conventional concrete. And then it gets smaller from there down to powder. But there's no special secret sauce. It's all things everybody would normally recognize in a concrete mix. It's just the calibration of that material and the processes to mix it and the processes to pour it and the process to cure it that gives it some outstanding physical properties, such as conventional concrete, maybe 4,500 PSI. UHPC is starting at 13,000 PSI, and there are lab formulations not available for use in the world that can get up to 20,000, 25,000 PSI. But we make thin stuff that hangs on a building, and our focus is flexural strength, even though we do have very high, up to 18,000 PSI. Compressive strength, that is not the critical factor. The critical factor is flexural and, the strength of the attachment of the panels. And part of what helps us with that flexural strength is that we include, and now you've seen it's changed from UHPC to AUHPC. So we don't have steel fibers, which is very common in the civil application of UHPC, but we do have glass fibers and glass mesh. The primary reinforcement of our panel is the glass mesh, which is why we say textile reinforced. And this allows us to make very large panels that, are only 5/8 of an inch thick. Now, concrete has a bad rap in terms of its environmental impact, and it's not because it sits so high on the chart compared to other materials, it's because we use so much of it. So what we're doing with our material is we're taking the kind of science that develops something for severe and conditions in civil engineering applications and bringing it into the architectural product line. Just a quick comparison of a precast profile on a building and how it changes in thickness and weight if you did it with UHPC. So some of the things that architectural UHPC is really good at is, as we said, it's impermeable, it's watertight. It has great impact resistance. It's great for all kinds of climates. Resistant to water damage, as well as the chemicals in that water getting into the material and degrading it. We've been installed in seismic zones, and we're constantly reducing our emissions with every new formulation that we work with. Just an example of, water absorption below the measurable limit. We have projects that take the material straight into the ground. Normal concrete or precast would be soaking tannins and things from the ground, and you would start to see stains migrating up from the ground on the panel. That does not happen with our material. Here's an example. Some planters made of our material. We actually used to make this sort of thing. Filled with soil for many years, only 1/2 inch thick, out in the weather. There's no soil staining, as you can see, migrating through that material. We've tested our material for impact, both hard body, soft body. I don't know if we have time, but so that's the typical test. It's basically a hammerhead of 2 inches diameter with a 150-pound load of force hitting it. That's hard body. Soft body.
At 9 foot, go.
Soft body is a big bag of
At 9 foot,
steel ball bearings swung at it. Both of our tests, we had to modify the setup to ultimately find failure. But what you saw was the standard impact testing that the normal test goes to a limit. In the end, we exceeded by a wide margin both tests before we found failure. And that information is available with all the rest of our testing data. We do have an FPPA test for a typical cavity wall type construction. The material is also non-combustible. We have both the Canadian as well as the US versions of combustibility tests, as well as smoke and flame meets the Class A fire. And when it comes to water, it's the thing that almost any material eventually is going to succumb to: sunlight, water, right? A couple examples here. So the tall building, the coppery colored material is not ours, but the first 2 floors of this whole building is clad in our material because it's in the flood zone. The other image you're seeing here is our material that replacing all of the safety and sort of human comfort stations along the beaches of New York after Hurricane Sandy. And then we've also got, we mentioned before, a photocatalytic material. UHPC is very well suited to this because it does not degrade on its surface the way other concretes do. And the degradation of a normal concrete would prevent the chemical reactions taking place, whereas UHPC surface does not degrade. So it will continue for the life of the panel to be able to be activated. And then we talked about ongoing research and development. We've been working over the last 10 years. You can sort of see the generations of mixed development and how the cement quantities being reduced, which is the primary factor for embodied carbon measurements. And that's it. Did I take too much time? I know there's a lot of other things over this next year with Acelab specifically. We're going to be doing more presentations that will get more in depth on specific topics such as detailing, mold making, prefabricated wall systems, and so forth. So I hope you all can join us in the coming months for or look out for those presentations.
Yeah, definitely. Stay tuned for some more presentations from Tactile. We're really excited to be working with them to bring this content to you all. So I want to put a reminder for everyone. We've got some time for questions. So if you have any questions, feel free to submit those to the Q&A box. I know we've had a few that Catherine's been working hard answering. So maybe we can talk through some of the answered ones out loud. And, you know, they might be relevant to other folks as well. All right, so I'm just going to kind of go through here. I'm going to read some of the questions that we have and some of Catherine's answers. And then Kevin, if there's anything you want to add or just kind of discuss about these, feel free to jump in.
Okay.
All right, so we had somebody ask, would there be any expectation for efflorescence on finished products? Catherine had answered that one that the formulations are fine-tuned to be lower in cement than conventional concrete, which lowers the quantity of salt migrating to the panel surface and mitigates efflorescence. There's also a hydrophobic sealer that's applied to all of the materials before they leave the facility to protect against variable surface curing while the parts are still created. However, UHPC is still concrete, so efflorescence can sometimes be visible in the darkest integral colors, but that's not something that they see often.
Yeah, and I would only add that the incidence of efflorescence in our experience is due to water getting into crates before the material is able to be hung on the building. Once on a building, the panel certainly is going to get wet because it's on the facade of a building, but efflorescence is created by a time lapse of it being unable to dry out evenly. So with ventilated facades, you have quick, even drying whenever something gets moisture. Whereas when it's packed tight in a crate and it's not properly covered, then you could get into trouble with water sitting in between panels and not drying out. And that's usually where we see staining that is akin to efflorescence in terms of a white stain on the panel.
All right, we've got quite a few open questions still, so let's help Catherine out and answer some of those out loud maybe. Somebody asks, can larger aggregates be used to produce a PEAF-like finish, PEAF in all caps?
I'm not sure what a PEAF finish is.
Yeah, if you can give us some more clarity on that, that would be awesome.
But if, I don't want to, if we don't get that, so the larger the aggregate, the thicker the panel. So up to about 1/8 of an inch diameter added material on the surface, we can do without changing panel thickness. But then when it starts to grow, the thickness will grow because we don't want that added material, which is not UHPC, to interfere with the way the panel behaves structurally, and we don't want it to interfere with the layers of mesh that we've got inside the panel.
All right, this person included some clarification that they mean poured exposed aggregate finish.
So I'm imagining like a resist and a power washing of something. What we do basically is we broadcast the, let's call it aggregate, decorative aggregate, onto our molds, and then we pour over that. And then we blast the surface to expose it. Otherwise, depending on what color and size that aggregate is, you may not even see it unless you blast the surface. So there's different levels of blasting. There's of course different size and types of aggregate, and it depends on what those are. But to get like a pebbly looking surface, probably not.
Okay, cool. All right. Let's see, I saw another question that came in about like pricing information. We've also got Jefferson asking, is there an estimated cost per square foot? And specifically a 5/8 inch base and up to 1.5 inch thick. And then the other person who had asked about pricing information had asked, maybe I lost it, but just kind of like general pricing information in comparison to some other facade materials.
Okay, pricing, I'll say this, pricing in a vacuum is very, very hard to do.
Yeah.
Because there are too many factors. So I'm hesitant to throw out just cost per square foot because it depends on the size of the project, as we discussed, sheet utilization, number of unique parts, what the wind loads or seismic considerations are for the project area, panel sizes, etc. But I will say this, if it's a very efficient use of the material in terms of panel size and utilization, it's a reasonably sized project, meaning 10,000 square feet or more, and not a lot of unique special panel parts and sizes, and a moderate wind load, which we're not seeing very much of these days. The panels will cost in the neighborhood of $20 a square foot for standard 5/8 inch, right? Meaning we didn't make a new mold set for the project. And it's only 5/8 of an inch thick. Above, in that range, it also doesn't matter whether it's custom color or not relative to price, unless you ask for, I want a deep blue or deep red. Even the addition of aggregates is not going to change that number very much. But the caveat is that the pricing becomes very specific to the project, not only for the panels, but for the hardware to hang it.
Mhm.
What we always recommend, folks, is send us an elevation, send us a wall section, even if it's a half-baked, very early concept sketch, we can give you feedback on what the costs might be,
Mhm.
as well as other technical feedback to help with your design work.
Cool. While we're on that topic, I know we briefly covered this in the intro, but I think this could be a helpful time to kind of share how you can get in touch with Tactile on Acelab and some of the benefits of doing that. So I'm going to share my screen really quick and just show you guys this again. I just dropped a link in the chat for coming to this page on Acelab. Is everyone able to see my screen? Let's see. Kevin, would you mind? Oh, it looks like someone in the chat.
Oh, I have to give it up, stop share.
Yeah, if you could stop sharing. All right, cool. And then here we go. Awesome. Yeah, so for project specific questions, like pricing, as Kevin was saying, having some drawings, some elevations, some general project info is super helpful for the Tactile team to be able to answer those questions. So one of the ways you can get in touch with them is using Acelab. Everyone who signed up for this webinar has a free Acelab account automatically made for them. It's completely free to use. So you can go ahead and click this contact button, and then we'll ask you to nest that under a project. So everyone automatically has just like general research project as an option. But you can also add a project. I've got a ton since I'm always creating new ones for testing purposes, but you can add a project right from this page. So it's super quick to do so. We only ask a few questions, but I'm just going to show you kind of the benefit of doing that. So I'll select one of my existing projects. You can let us know if you're looking for a specific product. You can also skip that. And then say you're looking for pricing information. You can check that off to connect with the expert. And then you can go right over to this conversation. And one of the great things about using Acelab as a conversation portal is once you upload some of those project details, they're all saved right here on this left-hand side on this menu. So if you want to submit documents, include some images, some general budget information and your location, the Tactile team will be able to see that right away. You're both going to be able to access that every time you're communicating with each other. So it really helps to kind of cut down on the time spent maybe going back and, finding the project info, copying that over, sharing it with somebody in email, and then that gets lost. Once you set up that project, you can reach out to multiple folks, get a bunch of pricing information, compare it on Acelab all in one place. So this is a great place to come after today's webinar. If you've got some project specific questions, you want to be able to reach out to the Tactile team and communicate that information efficiently. You can use our conversation portal over on Acelab. And a question that always comes up about this is, is it secure to upload my project details onto Acelab? Yes, it is. We don't share any of that information without your consent. It's just when you decide to reach out to a manufacturer and share that information in order to be able to discuss a project with them. So uploading your information is, safe to do. And it's really just when you decide to reach out about a specific project that that information gets shared. All right, so hope that's helpful. But yeah, if anybody has any specific projects, feel free to use Acelab to get in touch with today's presenters and start communicating about those project needs. All right, looks like we've got 5 minutes left, and I see there might be a few more things in the Q&A box. Okay, people were answering me about screen share. That's awesome. Thank you, guys. All right, I'll put in one last call for any last minute questions if anybody has those. If not, we can let folks go a few minutes early. But just want to thank everybody so much today for coming to today's webinar, for participating in our polls and our question. Really appreciate everybody's engagement. And thank you so much to Kevin and Catherine for joining us today, sharing information about Tactile's products, and helping out with answering all these great questions. All right, looks like I'm just seeing thank yous in the Q&A. So if we're all set there, if anybody has follow-up questions after the event, again, head to Acelab, get in touch with today's presenters. We'll be happy to answer any questions over there. All right, cool. Thanks, everyone. Thanks,
everyone.
Kevin. Thanks, Catherine. Bye.
Thanks. Bye.
Bye.